Hello students, and we take the problem 5. Okay, then we solve this differential equation. This is the second order differential equations, and we solve this by the series methods. Okay, then this is to y double dash minus y is equal to 0. Then we take its solutions. Okay, as y is equal to the summation from n is equal to 0 to infinity cn and x to power n. Okay, and then we take the first time derivatives. Then this is n is equal to 1 from infinity and cn and n and x to power n minus 1. Again we take the second time, because here is the second time derivative here. Then this is from n is equal to 2 up to infinity n into n minus 1 is cn and x to power n minus 2. This is so simple. Okay, simple derivative rules. Okay, then we put the value of y, okay, and the y double primes here. Then first we put here from n is equal to 2 to infinity, okay, n into n minus 1, okay, and cn and x to power n minus 2, and then minus this ones, and from n is equal to 0 to infinity and cn and x to power n is equal to 0. Okay, now we first put the value of limits for n is equal to 2. Then this is x to power is 0, and then we put here this is also 0. Okay, then we is take this power is, let's n minus 2 is equal to m. Okay, then the n value is equal to m plus 2, and the limits of m is equal to, we put here the value of n, then this is the m limit is goes to 0. Okay, this is for this one, and now for this is the n is equal to m, then the limits of m is simple as 0. Okay, then we substitute this value into this equation. So then this is from m is equal to 0. Okay, the m into m plus 2 and m plus 1, okay, and x to power m minus summation from m is equal to 0 to infinity is cm and x to power m is equal to 0. Okay, then we take common from m is equal to 0 to infinity, and the m plus 2 and m plus 1 minus and cm. Let us look here. Here c is m plus 2. Okay, here we write the cm plus 2, and then here we write cm plus 2. Okay, and cm plus 2, okay, minus cm, okay, and x to power n is also common here. Okay, then this is not equal to 0, this 2, then this coefficient has become 0. The m plus 2 and m plus 1 and cm plus 2 minus cm is equal to 0. Then this is cm plus 2 is equal to cm and divide by this 2 term as cm plus 1 and Cm plus 2. Okay, now this is the recursion relation. So okay, now then we find the value of the C1, C2, C3 and so on. Okay, and first we put the value of m is equal to 0. Okay, then the C2 for m is equal to 0, then this is C2 is equal to C naught divided by 2. This is 0, this is 0, and this is divided by 2. Okay, now for m is equal to 1, then this is C3 is equal to C1 divided by 6. Okay, and for m is equal to 2, then this is 4, C4 is equal to C2 divided by 12, and we put the value of the C2 here, then this is C naught divided by 24. Okay, okay, then for n is equal to 3, for m is equal to 3, then this is C5 is equal to C3 and divide by 20. Okay, and then we put the value of the C3. Okay, then this is equal to C1 and 120. Okay, now we put this value, these constants value into the equations, the above equation, to we take its solutions. Okay, then the x solution is y is equal to summation from n is equal to 0 to infinity is Cn and x to the power n. Okay, then y is equal to, this is C naught, C2, C1 x plus C2 x square and C3 x cube and C4 x4 and so on. Okay, then we put the value of these constants here. Okay, we put this value into this solutions, then y is equal to C naught plus C1x, and the value of the C2 is C naught divided by 2. Okay, and x square, and then the value of the C3 is C1 divided by 6 x cube, and then the value of the C4 is C naught divided by 24 x to the power 4, and then plus the value of the C5. Okay, this is C1 divided by 120 and x to the power 5 and so on. Okay, then we can rearrange these equations and in term of the C naught and in term of C1s. Okay, then first we write in term of C naught, we take common, then this is 1, and let us look here, this is plus x square divided by 2, and then plus this one is x power divided by 24 and so on, and then plus C1 is x. Okay, and then plus this one, okay, is x cubed divided by 6, and then this one x5 divided by 120 and so on. Okay, then C naught, and we write this in the form of summations. Okay, then n is equal to 0 up to infinity, and let us look here. Here the x to the power is 0. Okay, and then this is x to the power n divided by n factorial. Okay, this is 2 factorial and this is a 4 factorial. Okay, and then plus c1, and we can also write this in the summation form as from n is equal to 1 to infinity as x to the power n and divided by n factorials. Okay, then we solve this differential equation by the elementary methods. Okay, this is the solutions. And now with this equation is solved by the elementary method, then the equation is y double dash is equal to y. Okay, then the y double dash is equal to minus y is equal to 0. Okay, and then this is like this. Okay, then this d divided by dx square v is equal to d square. This is the the derivative operators. Okay, then this is d square y minus y is equal to 0. Then d square minus 1 y is equal to 0. And then the y is not equal to 0, then this is equal to 0. Okay, and then the value of the d is 1 and squared, then we take under root, and the value of the d is plus minus 1s. Okay, and then the its solution is like this is as c1. Okay, and e to the power x and c2 and e to the power minus x. Okay, this is the solution of this differential equation by elementary methods. Okay, thank you.